Hello. Some time ago I started working on this beautiful Superbeta video recorder, but I came a bit unstuck because of what appeared to be counterfeit parts. This was the original STK5441 power supply regulator IC that was in the unit, and this didn't work. The machine didn't run properly at all, and it became fairly obvious that this is a counterfeit component. It's probably some other regulator. I ordered from China this, and the machine sort of worked, and at one point it actually fully worked for a few seconds anyway. But this machine, this part, I also have some doubts about. But I've decided that since I can't get another part at the moment, I'm going to refit this and see if we can actually test the machine in a little bit more detail, see if there's some problems with the power supply, or if the fault that we were getting is actually unrelated to the power supply. And the fault we were getting is that it would do crazy things. The sensors around the deck were doing mad things, like lacing up when there was no tape in there. It wasn't one sensor, it was all the deck operation was very strange. So it may be that there's a problem somewhere around where the sensors connect to the microprocessor that deals with the deck operation. Unfortunately, this has been lying around so long, I've found that I've actually damaged the circuit board. So just a little bit of glue on the power supply circuit board, I'll let that set, and I'll completely reassemble the power supply, and then we'll try to do this a little bit more scientifically, see if we can find out if there's a problem with the syscon electronics, and perhaps the power supply itself is not the cause. Right, down in that slot is where the regulator is mounted to this heatsink, and we've refitted the power supply to the machine. So when we last looked at this machine, the syscon was doing crazy things, like lacing up without a tape in it, and I believe that's also probably why it damaged the mechanism, because it got to the unlace and carried on driving and was damaging itself. So we need to be super careful about powering this up. But I'm going to look at the power supply pins on the syscon chip. So before I even power it up, I'm going to set a meter up on the SS32 board. So that is this board, this chip, and pins 34 and 12 are supposed to have 4.7 volts on them. So I'll set up a way of measuring that. We can look at the voltage when we power it up the first time. Okay, we're almost set up. So I have 110 volts ready to apply to the power supply. I have this multimeter set up between pins 11 and 12 of the syscon chip. But what I really don't want it to do is overdrive into the unlaced position and snap this plastic component yet again, because I'm struggling to get enough of those replacements. But if it overdrives that, it just snaps that in half. So I'm obviously very nervous of what will happen. I have the isolation power supply over here. Let's switch it on initially and hope nothing happens while I just measure the voltage on this power supply, on the 4.7 volts. Here goes. Dead. Have I forgotten to do something when I reassembled the power supply? Right, we'll do that again. I had a misset switch on my 110 volt power supply, so we'll do that again. 4.7 volts. So that's correct. Right, it started lacing up without a tape in there, which is just madness. Power up again. Will it unlace? Okay, unlaced. And I think it stopped, but I switched it off before it did anything crazy. So we know we have the correct supply voltage to the syscon chip. That pretty much eliminates the power supply. I will set the oscilloscope up and just make sure that that supply isn't noisy. So we'll go 1, 2, 3, 4.7. We should sit up here, and we'll just check for ripple. That looks clean. Switch it off again. Okay, let's disconnect these wires I've soldered on for checking the power supply. Now you may remember that at one point I had this machine fully working and then it suddenly stopped working again. So there's something marginal that could work but isn't. And I believe the problem is around the syscon. I don't believe it's a mechanical fault because the sensors are all working. Now we have, this is the B2 type deck. It doesn't have a switch in the unlaced position. It uses the tape end sensor to also detect when it's in fully unlaced. There's the a switch here for detecting when it's in fully laced, and I've tested that switch in a previous YouTube video, so we know that that's good. Well, we had a problem with it initially, but it's now good. So what is this machine doing? We power it up again. It's running a motor, and then it starts doing crazy things like running motors. Well, it shouldn't be doing that. Not without a tape in there. So at one point it was lacing up as though it believed there was a tape in there, and there isn't. But we know there's nothing fundamentally wrong because it has worked in this case, in this assembly, and nothing's mechanically changed since it was last working. There is a possibility that there's an electronic fault or even a failure of the syscon chip itself, which would be extremely unfortunate. But you notice it's doing different stupid things each time I power it up. Sometimes it starts lacing, sometimes it's trying to unlace. What's it playing at? So if I lace it up a little bit, you can see I've laced it a little bit. You can see this is the part that it has a tendency to snap by overdriving, and when it unlaces, the way it detects that it's completed unlace is using this sensor here, which is the sensor for the end of tape, leader tape. It swings it round to see this piece of metal, and so it knows it's in a fully unlaced condition. On this particular deck there's no switch here, which the earlier mechanisms have. So everything there should be working. And if I lace it slightly, right, and power it up, it should, what should happen when you power it up is it should drive to the unlaced position and stop. Well, it sort of did. Now it's doing weird things. No, stop doing that. Would you believe that this sensor's faulty? It's just about possible, but in all my days of working on Sony Beta video recorders, I've never had one of those sensors fail. But it could be intermittent or something, so let's check out the wiring from this sensor. So it says tape top sensor and tape end sensor are L901 and 902. It's not incredibly clear to me which one they mean is which there. This would be tape top sensor, I would have thought, because it's the sensor that's used when you get to the start of the tape. So I believe that would be 902, and they go to an IC4. So we'll check around there. I'm checking for what should be continuity to ground on the sensor coils. So that's pins 1 and 2 of IC4. Pins 1 and 2 are okay, and then continuity from pins 3 and 4 through to the syscon chip. Okay, could IC4 be at fault? I might call that one, because the thing is, it has worked. So if I can get to that chip, I'll cool it. Can I drop this board down while I'm working on it? Okay, I've just cooled that IC4 a bit. You can hear the real motor spinning. and then it does that, which it shouldn't do. No, it's starting to lace without a tape in there, right? So lacing without a tape in there means it thinks the cassette down is met, and it isn't. So we're definitely seeing weird things going on with the syscon. I reminded to myself, where are the cassette down and record switches? Are they here? They don't look quite set up right. I think we'll need to drop the reel table and check the switch for cassette down and record proof. No, that's not fitted right, is it? That's all wonky. Aha! That's had a bit of trouble when I obviously put it back in last time. You need to line these up quite carefully with these slots. If this board gets so in the way when you're trying to reassemble this. Oh no, I've knocked something else off. Oh, this is awful. Right, that's the back tension band. Okay, that looks like it's correct. Let me check that both of those leaf switches have come through the deck. Yes, there they are. So now I can refit this board assembly. Okay, we now properly have those two leaf switches there. I hope I have the back tension arm correctly set, because that mechanism is a bit odd and I don't really fully understand how it's supposed to be configured. Right, power it up. Still not quite right, is it? What happens if I put a tape in it now? You see, it's still doing stupid things. It's still seeing a tape in there when there isn't one. Okay, I'll have to meter out the switches to find out why it thinks there's a tape in there when there isn't. I've set up a wire now looking at the point which detects the resistance supplied by a set of switches. Those switches being cassette in, record disable, and loading complete. The system applies resistors to those points so that it measures which of those conditions is true. Obviously they were constrained by the amount of input pins they had on the syscon. So load end should take this point to ground. Now load end is this switch here. It's a little bit tricky to get to, but I'll come to that in a minute. We should be able to detect when the record prohibit switch is operated and the cassette in, and I'm not seeing anything. I should see resistances there. Maybe I'm not in the right range. Let's just set it to auto range. That's better. So we're reading about 11k. If I operate, there we go, that changes. That's either cassette in or record prohibit, not quite sure which, and this is the other one. Yes, so those two switches are working, and I'll operate them both together and you get a different reading again. And I'll manually operate the loading complete switch. Yes, that one, when it is made, shorts this to ground. There we are, grounds it. So the way I think it works is it only reads these switches at certain times. So when a cassette is first put in and it drives the carriage, it will then look for the cassette in and record prohibit switch, and once it's ascertained that the cassette is in and knows whether or not it's permitted to record on it, it stops listening to those switches again, and is only interested then in whether the lacing is completed once it's driven the lacing motor. And all of those signals appear to be going in correctly. So this asks the question, why is it that when I offer up a cassette and it sees there's a cassette in the carriage, that before it's even loaded, it assumes that it's already completed loading and that the cassette is in place when it clearly isn't? What I think I'll do is I'll look at the voltage on that pin in various conditions. So I'll power it up and just look at the voltage on, it's the input signal before it goes via a resistor just before pin 16 of the syscon chip. So it goes via R30, which is 1K, but that shouldn't alter the voltage it sees. Okay, let's look at the voltages as we power up the machine. So switch it on. It's up to 5 volts. Well, 4.7 volts. And when I offer up a cassette, that's just not logical, is it? That it starts lacing before the tape is in, before it's not even trying to drive it down. I'm going to unplug this P10 connector that goes to the switches and measure the resistances we get just on this, because I'm getting some slightly mixed readings from reading it on the board, because of course it will be measuring to not just ground but also leakage paths via supply. So this way we'll measure just the switches and their resistors to ground. Okay, the circuit diagram's not terribly obvious, but what you've really got is a 3.6k resistor in series with the switch arrangement, and then a 10k resistor and a short circuit. So you operate one of the switches, you get 13.6. The other switch, you get just the 3.6 when you short circuit it. So I think that's the record prevention switch, and that's the cassette in. And if you operate both of them, you get 3.6 because you've got a short circuit across the 10k one. Right, that makes sense. So here are some of the guides, and some of them are quite well hidden on this machine because they actually pop out during the lacing up. So there's a guide there which you couldn't see when it was in the unlaced position. It pops out there. There's something wrong here. That's jamming up. So I was filming some material for an unrelated YouTube video and was demonstrating something with this Superbeta machine. And then looking at it, I realised there was something wrong, because as I was winding this to make it lace up, it was getting difficult to lace about halfway through. And I thought, well, that's just not right. There's mechanically something wrong here. I took this assembly off and could find nothing wrong, so the problem lay further back here. I realised there was a problem with the solenoid. This solenoid here has got two tasks. One, it directs power from the motor either down to the gears through here, down to the lacing mechanism, or up to the belt here and the front loading to take the cassette in. And you'll remember that it was driving this lacing when it should have been driving down, and I was starting to wonder if we had a problem with the actuator here. So I just looked and I could see that this was all snarled up, and I just pushed it back into place. Clunk, everything worked. So the machine was behaving sensibly. It was driving the correct motor in the correct direction at the correct time, but it was mechanically jammed up and the drive was going to the wrong place. So now the whole mechanism works just fine. Let's demonstrate. So I've just powered it up, switch it on, goes clunk. They do like a clunk, and there's one of the clues that it's now happy. Let's pop in a tape. They do stop at part lace position for some reason, and we can fast forward and play quite happily and get a picture. And now for eject. So our Superbeta is now properly fixed. How did it get itself into that wonky position? I don't know, but I've exercised this machine quite a few times and it's now working absolutely fine. So this Superbeta is now in full working order. You know, it first arrived about a year ago and I've only just finally sorted it out. And you remember, if you saw the first video, that it came with this rather wonderful remote control. The display is a little dim. That's just typical of an old display. There's nothing we can do to fix that, unfortunately. Oh, something else I wanted to show you on this remote control is it actually has an eject button, which is fairly rare on a video recorder, because of course if you accidentally press that button you then have to get out your seat to put the tape back in. This is presently playing a Beta 1 speed tape, because in NTSC land Beta came in 3 speeds. I have noticed that the tracking seems a bit different on Beta 1 compared to Beta 2 and 3, but that could be the tape itself, or it could just be a limitation of playing Beta 1 tapes on this kind of machine. The transformer on this machine looks like it has extra windings that would allow me to convert it to 240 volt, which maybe I could do, but it's a little bit scary. Get it wrong could be a big bang, so I'm not going to do that right now. Something else I wanted to mention is the contents of this bag here. We had some trouble with this and other machines, including a Beta Hi-Fi, with a particular gear here, and this gear is in the lacing mechanism. It's fairly easy to get to, fortunately, and it tends to split. And you can get gears for remote control cars quite cheaply on eBay, and these look like a good fit. I'll show you them under a microscope in a moment. I can't even begin to tell you how happy I am to have this machine working. Like I say, it's been with me for a year. You could probably count the amount of NTSC Superbeta machines there are working in the UK on your fingers, and now there's one more. If you had to say what's my favourite video recorder, and you know I'm a bit of a nerd when it comes to video recorders, this is going to be certainly in the top 10. I love this machine. Right, let's have a look at these gears. So here are the gears intended for a remote control model car. and let's compare them to the original. So here's my broken gear. You can see it's been glued, but there's a gap there, so that's never really going to work. And here is what we've ordered. Well, certainly the teeth look to be a very good match. The height of the gear compared to the original is a little less, but bearing in mind there's no teeth on this part of the gear, so the actual usable part is fairly similar. It's maybe a fraction of a millimetre shorter, but you can place this in the middle of where it engages and that'll be fine. And finally, will it fit on the shaft properly? Yes, that looks an absolutely perfect fit for the shaft. Maybe a dot of your favourite glue. Mine would probably be epoxy resin, but you could possibly use super glue or similar to fit it firmly onto the shaft. Make sure it never spins. So yes, I'd say they're an absolutely brilliant solution to the broken drive gear problem that applies to lots of Sony Beta decks, more or less from the SLC-20 onwards. Now, one of the reasons I bought this Superbeta machine was that I'd had in some tapes from America that were Beta 1 speed, and that was okay because I have a Beta 1 player to play them on, which I've featured on YouTube before. But it gave terrible pictures because they were almost certainly Superbeta recordings. And my understanding is that this will play Superbeta 1 type recordings. It can't record them, but it can play them. So that's a win. But there's some confusion because it turns out there's two versions of Superbeta, at least two versions. And as well as regular Superbeta, which this supports, there's super high band with a different frequency set. And whether this can play that, I'm not certain. I've seen information that says it can and information that says it can't. So if you know if this model supports Superbeta high band, please let me know. But actually what I'm going to do is contact that original customer and say, send me one of those tapes I couldn't do last time and we'll try one. Another feature this has is a PCM selection here. And what that does is disable the built-in dropout compensator. And that's useful for when this is connected to a PCM decoder such as PCM F1, 501, 601, 701, I've got all of those, type decoder for digital audio tapes. And now I already have an SLC9 which has this PCM switch on the back for playing PAL tapes, but this is the first NTSC machine I've got with the PCM switch, which improves performance with PCM digital audio tapes. I'm absolutely delighted with this Sony SL-HF600 NTSC Superbeta machine. I'll do plenty more content on audio and video technology in the near future. Bye for now.